So what we're going to do is we're just going to look at what the nth term represents. Okay, if I want the nth term, then I need to know the n minus 1 term. I need to know the term that happens in front of it. So if I want the 10th term, if this is going to be the 10th term, my answer will be the 10th term, then I need to plug in the 9th term, okay, into this equation. Another way of saying that is this. If I want to know what I'm going to get right now, then I need to do 2 times my previous number, right? And then plus 1. That's even a different way of writing this. That's me changing this from algebra into just kind of words. So if I want to know the new term, what I want right now, I'm going to take what I had, multiply it by 2, and add 1. That's what this one would tell me. Okay? So let's run through this one real quick and see what we get. I need the first 5 terms. Can anybody tell me the very first term?
0.
Not 0.
No. 5.
It's 5 because I told you right there. Okay? So 5 is my very first term. Now I've got to find the second term. How do you find the second term? Well, in order to find what I want now, I'm going to do 2 times the previous term, which in this case is 5. Add 1, so I've got 2 times 5 plus 1, I get 11. So 11 is my second term. In order to get my third term, I'm going to do 2 times 11, because 11 is my new previous term, plus 1, and that ends up being 22 plus 1 is 23. And I do it again and again and again. So 2 times 23. Notice what you always plug in. What you plug in changes every time, doesn't it? Okay? So, what was that? 46, 47? And then finally, you'd have 2 times 47 plus 1. And what did we say that was? 95. All right. And of course, you could keep going forever and forever and ever on that, but I just asked for the first 5. Okay? Some books, I think the North Carolina Final Exam gives it this way, which is why I need you to understand how it reads this way. But I think your book gives it to you this way. And do they mean the same thing? And yes, they do. Okay? What they're trying to say, these pieces are the same, and these pieces are the same. But what they're trying to say is, up here, A sub 0 stands for the initial term, and a lot of times for the initial term, we say that there's been 0 times that this has happened. And then after the first time it happens, that'd be a 1. And after the second time, it'd be a 2. Well, when I write it like this, most of the time what they're trying to tell you is the first term. So if I want the first term, I do A sub 1. If I want the second term, I do A sub 2. And to a lot of students, this way makes more sense. So your book uses this terminology, whereas the final exam is going to use this terminology. Okay? The way that I read it is up here. Remember I was using the words next to now? Or I was using now and previous, I mean? The way I read it is like this. This would be now, my now value is going to be 2 times the previous, we wrote this down a second ago, plus 1. But if I did it the other way, what it would be saying is my next number would be equal to 2 times my now number plus 1. And if you'll think about it, they're really the same thing. It's just in 3 different parts. If here's now, and here's previous, and here's next, the purple one up top, this one is just using these 2 numbers to make the sequence, and the red one is just using these 2 numbers to make the sequence. But it's still using 2 in a row, right? And that's the key to these recursive. So this would be my now term, this would be the initial term, right? The B sub 0. This would be saying that my now term is going to be 3 times my previous term plus 1. Okay? So if that's the case, then I'm just going to go through. I'll tell you what I'm also going to do. I'm going to cut this down to just doing 4. I could do 5 in a row, 6 in a row, but I'm going to cut it down to 4 just for time. So so let's figure this out. What would be my very first term? 2. All right, so I'm going to put these at the bottom. 2 is my very first term. Okay, no, that's a dumb place for it. 2 is my very first term. So my second term would be what? My new term
7.
is going to be 3 times the previous term, which was 2, plus 1. So you see it's going to be a 7. And I agree with you 100%, 7. Okay, and then I do it again. I have to do 3 times. What do I plug in this time? This time I plug in the 7. So 3 times 7, 21, plus 1 is 22. And then I can do it again. And what am I plugging in here? This time I'm plugging in the 22, right? And that's going to be 66 plus 1, 67. All right, and of course that does go on. All right, any questions? We're going to rewrite this one as next and now. So instead of starting at CO, I'm going to start at C1 and call it -2. And what would this look like if I rewrote it as next and now? Instead of Cn, it's going to be C sub n plus 1. That's the next term. Is going to be equal to my now term, which is just C sub n squared, plus, now the n still stays. Now, I just wanted you to recognize that these two ways of writing it are exactly the same. But some books prefer to write the equation as Cn, and some like to do it as Cn plus 1. This just means my next term is going to equal my now term squared plus n. Okay?
What's in the parentheses? Yeah, I can't read that.
C sub n. What is my first term on this one? It is -2, so that one was given to me. Now to find the next term, so this represents C sub 1, right? So n plus 1 would be 1 plus 1. That would be C sub 2, right? So C sub 2 is the next term. That's going to be C sub 1 squared plus, what am I going to add? Think about that for a second. I'm actually adding, see that was an n, and n is my second term, so I'm going to be adding an actual 2 right there. Because this n isn't part of a recursive part, this is actually more of my explicit part of the formula. So if I plugged in a 2 here, then that's going to be a 2. All right. Actually, I misspoke, didn't I? That's 1 plus 1. That should be plus 1. I am so sorry. That's actually a plus 1 there. Mistake number 1 for the day. All right. I know. Pretty good. I made it till 3 o'clock. Almost 2 o'clock. Mistake number 2. All right, so this is going to be C sub 1. What was C sub 1 again? It's -2, right? So I've got -2 squared. And then I add that 1. So -2 squared plus 1 is 4 plus 1 is 5. So that answer is a 5. So my second value is a 5. Oops. My second value is a 5. Now to find the third value, that's C sub 3, that's really going to be C sub 2 squared plus, what am I going to add here? Now I'm going to add, instead of adding 1, I'm adding 2 because I'm finding that next value, right? So that's going to be plus 2. So that's going to be, let's see, what is C sub 2 again? C sub 2 was 5. I can look at my table, and that was a 5. So I've got 5 squared plus 2. That's 25 plus 2 is 27, right?
25 plus
And then I've got one more to do. I think I've got room for it off to the side. I'm going to erase some of this. So now in order to find c sub 4, I got to do c sub 3 squared plus, what am I going to add? Now I'm adding a 3. See how that changed every time? Because of the n. Because it was an n that changed every time. It was a 1 and then a 2 and now a 3. So my c sub 3 was 27. So now I've got to do 27 squared. I'm going to need some help with this one. Plus 3. And you said that final is what? 678. Is that already with the 3? All right, 678.
What?
It's 732.
It's
Oh.
732.
Well, okay. 732, 678. Whichever. You just need to go through and do 27 squared plus 3.
Yeah.
Okay, so this is a famous one. The 0th term right here is 0 because they gave me that. The first term is what? 1 because they gave me that. Now I have to find the second term. So to find the second term, I'm going to use my recursive formula. So I'm going to plug in what they've given me. So this is what it's really trying to tell me is f sub 2 is going to equal f sub, now eventually I'll quit writing this, but that's 2 minus 1. 2 minus 1 is f sub 1, right? Plus 2 minus 2 is 0. So this is what I'm really looking to do. I'm really looking to find f sub 2 is going to be f sub 1 plus f sub 0. So I've got those in my chart. That's a 1 plus a 0, and the answer is 1. So I can come up here, and I can put in a 1. Now to find f sub 3, how does that change my formula? Now it's going to be f sub, let's see, 3 minus 1 is 2, right? So this is f sub 2 plus f sub 1. And again, those are already in my chart. So f sub 2 we just found out was a 1, and f sub 1 was already a 1, so 1 plus 1 is 2. Now, in order to find f sub 4, I'm going to do f sub what? 3 plus f sub 2. And in my chart, that's 2 plus 1, which gives me a 3. Right? And I got room down here for one more, so I'm going to find f sub 5, and that's really going to be f sub 4 plus f sub 3, right? And 4 plus 3, it's not really 4 plus 3, right? It's not really 7. It's really f sub 4, which was 3, plus f sub 3, which was 2, and 3 plus 2 is 5. Does everybody kind of see the pattern? All right. So what I need you to do is I need you to go through and find the rest of them through 10. All right? So I want to take a few minutes to go ahead and find 6, 7, 8, 9, and 10. So guys, this is a very famous one. It's called the Fibonacci Series, and I just forgot.
Never heard
I think it's 1N actually.
You are a liar.
Hey, what is that? Okay, you know, it's like a book, and it has this.
It's like the
in it.
rods or something.
Yeah.
Fibonacci sequence. I'm going to show you online a couple things. All right. The Fibonacci sequence is designed. It was a pattern designed by this Italian. He's able to figure it out. But what ends up happening that's really cool about it is that it shows up a lot in nature. Okay? And down here, here's one of the things that it shows up for. This is a really cool situation. I hope you recognize in this situation here that way in here, if you were able to zoom in, it's hard to see, but there's a 1-by-1 block, okay? Looks like this. Well,
Oh.
looks like this. It's 1-by-1, okay? And then I put another block right beside it that has to share the same side. So if it shares the same side, how big does it have to be? Oh, it has to be another 1 by 1, doesn't it? And now if I put a block here that shares these sides, how big is that block? 2 by 2, and you can probably start to see it now. Now down here, how long is this block? That's a 3 by 3 block, and now you can see where they're at. And then, when you add those together, you get a 5 by 5 block. And as you can see, you've got 1, 1, 2, 3, 5, 8, 13, 21, 34. And those are the numbers from the Fibonacci sequence. And if you connect them in such a cool pattern, they make what's called
Spiral of life.
a nautilus.
A nautilus?
Nautilus is an actual sea creature. It's basically an ocean snail. You're right. But you guys have seen these shells. On the beach, these shells aren't very big. They're a quarter, maybe 50-cent piece. All right? But they can get a little bit bigger. They can get bigger.
So like the size of a giant snail.
Where's the picture down here?
Giant. Like, you know, like giant seagulls.
There was a diver somewhere.
It felt like it had a creature on the inside.
So you can tell how big they can get. Here's this guy's hands.
I probably stepped on that one.
All right. In any case, what you can see, hopefully, is on the inside of this nautilus shell, you can see that spiral occurs, and this nautilus would just keep growing bigger and bigger, and it would just keep making that spiral.
Is it possible? Like, if we had one, like, put it in like a...
Well, a lot of times people prefer the explicit formula. They're easier, they're more straightforward, and that's fine. But sometimes, when we're not good at formulas, a recursive formula works out because it's more intuitive. So instead of writing the recursive formula, we're going to write, instead of writing the explicit formula, write the recursive. So we know that A sub 0 is going to be our initial amount. That's 1,500. So we're good with that. Okay? So we are good with that. But now we've got to be able to write this out. So A sub n, or the value after n times, is going to be, well, how do I do this? Let's see. This piece of equipment is going to lose 2.5% of its value. So how do I find 2.5% of its value? I'm going to take the value and I'm going to subtract 2.5% of the value, right? So, of course, that's kind of a rough sketch. Now I got to actually write it out. My value is going to be whatever I had to begin with, right? So that's A sub n minus 1. That's the previous thing. Minus, how do I write this whole 2.5% thing? 0.025 times A sub n minus 1. Okay? So what this is trying to tell me is that my now value is going to be my previous value, right? Minus 0.025 of my previous value. That's really what it's trying to tell me. And I would go through this over and over and over again. So we're going to go to a calculator now, and I'm going to show you a little trick on the calculator to work this. Here's your work for tonight.